Hello, my name is Mustafa Halain. I'm a one-level member in Double Trouble. I work mainly on the software engineering, which included the Arduino coding for the vertical and the robot arm. I also contribute with the construction of a project by building the vertical.
Hi, my name is Jessica Peters, and I was a mechanical and electrical engineer for this project, which involved the construction of the robot arm, soldering of wires, and the testing of the robot arm and car together with the controller. I did help out a little bit with the software portion for the car, but besides that, I did the final wiring and the casing for the car as well.
The whole reason why we selected this idea for the Capstone Project was because the people had the difficulty to perform those tasks that were too small or dangerous for the person. So we decided to build a vertical which you can control with a controller. And we also add a robot gripper so you can pick up and carry the object. The project was the biggest challenge we had faced because there were so many requirements to meet in order to make it successful. We saw the several drawbacks and made a big adjustment to fix the mistake in it.
Before building our project, we laid down the foundation of how everything would connect together by creating a block diagram of our system. In this diagram, it shows the complete connections of where each device is connected to. There are two Arduinos, one for the connections of the robot arm and one for the car. The receiver connects to both Arduinos, with the first two channels being connected to the second Arduino with the motors of the car, and the next three channels being connected to the first Arduino with the servos of the robot arm. With this, we were able to use one receiver and one controller to control both the car and robot arm at the same time. We had a battery to power up the servos of the arm, the motor driver, as well as the voltage regulator. The FPV camera was an easy setup which connected to a transmitter that was powered up by another battery. The receiver was connected directly to a phone and received real-time view from what was seen on the camera. With this block diagram, it made connections much easier to put together to complete the project. We began the process of building our project with the programming of the vehicle and testing its functionality with the controller using prototype connections. After confirming successful movement of all directions, Mustafa moved on to the programming of the robot arm and testing the functionality with the controller of all its different positions. The arm was then placed on the car and was ready to be tested with both the arm and car together. With the success of both working smoothly, we finished off by wiring all connections together and setting the placements of the Arduino, motor driver, batteries, and voltage regulator onto the base of the car. We topped it off with a casing, which included the implementation of a camera, and our RC car was ready to go.
This is what our finished project looks like. With the addition of a camera, we are able to see anything more closely. It is showing how the vertical and the robot arm are responding to the controller. Right now, the vertical is picking up the block on the floor. We are using the controller to move the vertical to different place and place the block. The camera also can let you see everything in long distance. It is transmitting to the receiver which connected to the phone. We can control the movement by looking directly to the phone. By looking at the phone, we can see the robot vertical driving to the garbage can and back toward the door while holding the block when using the controller. We can only see where it's going from the phone. In the end, this project has proven to be working successfully. Thank you for watching.
Thank you.